Imagine checking the weather forecast and seeing rain for tomorrow, then the next day, then the next. Now imagine that forecast never changing for 2 million straight years. No sun breaks, no dry spells, just an endless gray sky dumping water on a planet that was never built to handle it. This isn't science fiction. This actually happened roughly 234 million years ago, and it very nearly ended life on Earth before the dinosaurs even got their shot at global domination. Scientists call it the Carnian pluvial episode, but that clinical name doesn't do justice to what was essentially a 2 million year long natural disaster. To understand why this rain was so catastrophic, you first need to picture the world it fell on. This was the Triassic period, and Earth looked nothing like it does today. There was no Atlantic Ocean, no Pacific separating continents. Instead, nearly every landmass on the planet was crammed together into one gigantic supercontinent called Pangaea. This continent was shaped roughly like the letter C wrapped around the equator. Pangaea was a brutal place to live even before the mega rain arrived. Because the landmass was so massive, the interior regions were thousands of miles from any ocean, which meant no moisture-bearing winds ever reached them. The result was a supercontinent with a super desert at its heart, baked by relentless heat with almost no rainfall at all. Temperatures in the interior likely swung to punishing extremes, scorching by day and freezing by night. It was the kind of environment where only the toughest, most drought-hardened species had any business surviving. Life clung to the coastlines where the air was breathable and the ground wasn't literally cooking. Early dinosaurs existed during this time, but they were bit players, small and unremarkable creatures scratching out a living in the shadow of far more successful reptile groups. The dominant land animals were creatures called rhynchosaurs, pig-sized, beaked herbivores built like tanks with sharp, shearing beaks perfect for tearing through tough desert vegetation. Along with a menagerie of mammal-like reptiles that had been running the show since before Pangaea's deserts had even fully formed. This was their world, refined over tens of millions of years of evolutionary trial and error to survive one very specific set of conditions: hot, dry, and merciless. Nobody, and nothing, was prepared for what was coming. Then something happened deep beneath the crust that would change everything. In what is now Western Canada, a region called the Wrangellia Large Igneous Province tore itself open. This wasn't a single volcano erupting. It was a colossal system of volcanic fissures unleashing one of the largest outpourings of lava in Earth's entire history. A slow-motion eruption that lasted for hundreds of thousands of years. Picture magma not just spilling from one crater, but bleeding out of cracks across an area roughly the size of a small country, again and again for generation after generation of every living thing on the planet. There was no single dramatic explosion to mark the beginning of the crisis, no mushroom cloud moment. Instead, it was something far more insidious. A planet slowly poisoning its own atmosphere over hundreds of thousands of years, while most life forms had absolutely no way of knowing anything was wrong until the sky itself turned against them. The lava itself wasn't even the deadliest part. It was what came out of the ground along with it. These eruptions pumped staggering volumes of carbon dioxide and sulfur dioxide into the atmosphere, gases that don't just sit quietly in the sky. Carbon dioxide is a greenhouse gas, and in the quantities released by Wrangellia, it acted like someone cranking a planetary thermostat and then snapping off the dial. Global temperatures spiked. And here's where the chain reaction turns genuinely terrifying. A hotter atmosphere holds more moisture. A hotter ocean evaporates faster. The volcanic pulse didn't just warm the world, it supercharged the entire water cycle, loading the sky with more water vapor than it had carried in millions of years. That moisture had to go somewhere. It went down in what geologists now recognize as a series of intensified monsoon pulses hammering the supercontinent for roughly 2 million years. This wasn't rain in the way we experience a wet week in autumn. Picture monsoon seasons multiplying in frequency and intensity, arriving again and again with barely a pause between them, and drenching landscapes that had spent millions of years evolving to survive drought, not deluge. Rivers that had trickled through desert basins for eons suddenly swelled into raging torrents. Ancient dune fields, some of the largest desert systems the world has ever known, were buried under lake sediments and river deposits as the driest regions on the planet transformed into swamps almost overnight in geological terms. We know this happened because the rocks themselves tell the story with startling clarity. Geologists studying Triassic Age rock layers across Europe, particularly in the Dolomites of northern Italy and sites in the United Kingdom, found something bizarre. Sandwiched between layers of red, iron-rich desert rock, the unmistakable fingerprint of an arid climate, there's suddenly a thick band of gray and black rock, the kind that only forms in wet, humid conditions. Then, just as abruptly, the rock returns to red desert deposits above it. It's as if the planet's climate system briefly glitched, stayed broken for an almost unimaginable stretch of time, and then rebooted itself back to normal. This gray-red-gray sandwich has now been found on multiple continents, which is how scientists know this wasn't a regional storm system. It was global. Now, you might be thinking, more rain sounds like a good thing. Water is life, right? Under normal circumstances, sure, but this wasn't gentle, life-giving rainfall. This was ecological demolition. 2 million years of relentless precipitation triggered catastrophic erosion, stripping soil from the land and choking rivers and coastlines with sediment. Mountainsides that had stood firm for millions of years under dry conditions began sloughing away under the relentless battering of monsoon after monsoon, dumping enormous volumes of mud and rock into lowland basins. Entire ecosystems that had spent tens of millions of years fine-tuning themselves to a hot, dry, drought-tolerant world were suddenly drowning. Plants adapted to arid conditions couldn't cope with waterlogged soil and collapsed by the enormous fern and conifer forests that sprang up in their place. This transformed the character of entire landscapes within a geological blink of an eye. The animals that depended on those plants starved as their food sources vanished, and the animals that depended on those animals starved right behind them. It was a slow-motion collapse rippling up the food chain until almost nothing was left untouched. The rhynchosaurs that had dominated Triassic ecosystems for millions of years were hit especially hard. Their food plants, adapted to the old, dry climate world, couldn't survive the sudden shift to a soggy, hothouse planet, and rhynchosaur populations crashed alongside them. Many of the mammal-like reptiles that had ruled since before Pangaea's formation also went into steep decline, unable to adjust quickly enough to a climate that had essentially been turned inside out. In the oceans, things were just as dire. Rising temperatures and changes in ocean chemistry, likely including drops in oxygen levels caused by all that volcanic carbon dioxide, devastated marine life. Certain groups of reef-building organisms nearly vanished. Ammonites, once among the most successful ocean dwellers of the era, suffered a massive extinction pulse during this exact window. This is why scientists increasingly treat the Carnian pluvial episode as a genuine mass extinction event in its own right, even though it doesn't always get the same headline treatment as the asteroid that ended the dinosaurs 66 million years later, and even though most people have never even heard its name. And here's the twist that makes this whole event so wild. While the megarain was busy destroying huge swaths of Triassic life, it was quietly clearing the stage for the dinosaurs. Before the Carnian pluvial episode, dinosaurs were minor characters, small, scattered, and nowhere near dominant. They didn't have the numbers or the ecological grip to compete with the rhynchosaurs and mammal-like reptiles that ran Pangaea. But dinosaurs happened to have certain traits that turned out to be perfectly suited to surviving climate chaos. Many early dinosaurs were already evolving more efficient upright limb postures, faster metabolisms, and greater adaptability in diet and habitat compared to their slower, more specialized rivals. When the old dominant groups collapsed under the weight of 2 million years of nonstop rain, dinosaurs were among the few lineages positioned to expand into the empty ecological space left behind. Fossil records back this up in a striking way. Rock layers laid down before the mega rain show dinosaurs as a minor presence, a handful of species scattered among a much larger cast of competitors. Rock layers laid down after the rain finally stopped show a dramatic shift, with dinosaur diversity and abundance surging across multiple regions almost immediately once the climate stabilized. Within a few million years of the rain's ending, dinosaurs had gone from bit players to genuine major players, setting the stage for the next 165 million years of Earth's history. It was an era during which their descendants would grow into everything from house-sized predators to feathered giants roaming every corner of the globe. It's a genuinely strange thought experiment. Without 2 million years of relentless ecosystem-shattering rainfall, the dinosaurs might never have gotten their opening. The rhynchosaurs and their mammal-like reptile rivals might have simply continued dominating Pangaea for millions more years, potentially crowding dinosaurs into permanent irrelevance. Instead, a volcanic eruption on the other side of the planet triggered a climate catastrophe so severe it functioned almost like evolution's reset button. And the animals that happened to be built for chaos ended up inheriting the Earth. So the next time a rainy week has you feeling gloomy, remember the Carnian pluvial episode. Remember a version of Earth where storm clouds didn't part for 2 million consecutive years, where deserts turned to swamps, where entire dynasties of reptiles that had ruled for tens of millions of years drowned in slow motion, and where a group of unremarkable little creatures scurried through the wreckage and came out the other side as the future rulers of the planet.